All right, college biology, let's see if we can do with this. This is our energy video, and let's get to it. Energy is the ability to change matter. Right there. Ability, right there. There we go. The ability to change matter, and it is. So we got to discuss how matter can change. Well, there are a few ways that matter can change. One, you can change the position of matter. This cat likes to change the position of matter. It's here, now it's there, now it's there. Okay, good job, kitty. Matter position has changed. You can change the motion, how it's moving. This little buggy is getting faster and faster and faster. I guess it's a wagon. Well, whatever. The way they're moving is changing. Then we have structure. The shape of these proteins change. So the structure of the protein is changing. And then we have composition. So we have matter composed in these, organized in these molecules over here, but then a chemical reaction occurs and we have changed the composition of this matter. This is now made of oxygen and 2 hydrogen atoms as opposed to 2 oxygen atoms over here. So we've changed the composition of the matter. So the rules about energy, the first rule is that energy cannot be created or destroyed. This is called the first law of thermodynamics. And instead of that, instead of being created or destroyed, the energy is transferred. So the amount of energy you have at the beginning is the same as the amount of energy that you have at the end. You just have to keep track of where that energy went. Energy is always it's stored, but then when it's used or released, it goes somewhere else. So we can track that. Now, there are different categories of energy transfer. The first, elastic energy. This is energy stored in an object due to stretching or compressing that object. We have stretched this cord and this bow, and when we release, we're going to transfer it as another energy type to get that arrow to move. Another type of energy is heat. Heat has to do with the vibration and friction of particles. Cooler particles are vibrating less and have less friction. Warmer particles are vibrating more and have more friction. We have kinetic energy, the energy of motion. So we can see something move. We can see it changing in its position because of its motion, because of its kinetic energy. We can see electromagnetic energy, which is the energy of charges and electricity. We have chemical energy, which is energy stored in molecules that can be released or absorbed as those molecules change their composition. We have radiation, radiant energy, energy that travels as waves through the universe, like light. We've got nuclear energy, energy contained by the strong nuclear force in an atom that can be released and dispersed in great explosions. And then finally we have our cat again with gravitational energy, our cat's favorite energy type. Hey, let's change this position with gravity. Oh, it's the best. So gravitational energy pulling objects with mass toward each other. Let's proceed. Another concept about energy is activation energy, and this is the fact that objects need when particles, especially for chemical reactions, when particles are coming toward each other, they could bounce off each other and not have a reaction. And that is influenced by how fast and how hard they're moving. If we want to change the pathing of those electrons, then we need to have not only the right orientation, but also the right amount of force. So if we've got a lot of kinetic energy in those particles, those are going to collide more often. More of those collisions will be the right orientation, and more reactions will occur. So there's some examples of ineffective condition because the orientations are not right. And there are other examples of effective conditions where the orientations for collision are right. And we can't really control the orientation of collision. But if we have more energy in the system, then there will be more collisions and more of them will be effective, and so the reaction will occur faster. It's kind of illustrated in these little animations here. We've got a bunch of particles bouncing around. They're not the right orientation. They're not the right speed. But if we have these others bouncing around, I think they start changing color. That's kind of indicating a reaction, perhaps. And so we have effective collisions that are affecting a change. So if there's low kinetic energy, the reactions are not going to occur. If there's high kinetic energy, then you're over the activation energy, and the reactions will occur. And then there are enzymes. Enzymes lower activation energy. So if your particles have to be moving fast enough to jump over this to get to the reaction, then an enzyme will lower that energy. Well, what does that look like? How does it lower the energy? Well, it actually grabs the particles and mashes them together itself. So when it isomerizes, it mashes the particles together, so they don't have to be moving that fast on their own to begin with. And finally, we have energy of dissociation. This is the energy needed to break particles apart. So we've got this right here. We've got this particle, this molecule, and there's been some sort of energy input in the system that has disrupted the bonds, and now we've got two different particles because it was the energy that was absorbed was higher than the dissociation energy. So this is a long video, so we're going to try to review quickly. Boom. No, boom. See, man, this camera's weird. If I try to point at what we're doing, it's weird. Anyway, energy is the ability to make a change to matter, and changes to matter include position, motion, composition, and structure. The first law of thermodynamics is that energy cannot be created nor destroyed, but it is instead transfer. And energy transfer and story categories include elastic energy, which is stored in the structure of compressed or stressed objects, heat energy, which is the friction between vibrating particles, kinetic energy, which is the motion of particles, electromagnetic energy is the force of charge and electricity. Chemical energy is stored in molecular bonds. Radiation is energy which travels in waves and is actually very closely related to electromagnetic energy. Nuclear energy is contained by the strong nuclear force. Gravitational energy is the force attracting objects with mass. Activation energy is the amount of energy required to make a change, and for chemical reactions, if kinetic energy is too low, then the particles will repel if they get too close to each other, and they will not have an effective collision. But if kinetic energy is higher than the activation energy, then the collision will change the path of the electrons, and we will have a new bond. And finally, energy of dissociation is the energy needed to break bonds, and if energy is transferred to the particles is greater than the dissociation, then the bonds will break. I hope this helps. Struggle well. Sorry for the link.